Hello, hello. We got this. Okay, 8.4. Doing logs. Okay, we're gonna go back to the basics. Um, One main thing that you need to remember that logs are base. So I'm gonna write this really big. Log base b a equals e, which turns into base exponent equals an answer. Okay, that's going to be the key for today. So we're going to solve logarithms, meaning we're going to, basically what we're going to do is we are going to change forms to solve. Okay, you have to change forms. So whether it looks like this, we're going to go this way, but if it looks like this, we're going to go this way. Okay, we're going to go back and forth. So that's what we need to know this. Okay. So things to remember when solving: logarithms have domain restrictions. Okay, you can only take the log of positive values. So you're going to have to check your answers and make sure that they fit in the domain. Okay, when we get to that, I will show you in the examples. Okay, if you have answers that don't fit in the domain, they are called extraneous. Okay, solutions. It says these are imposters that aren't really in the domain. Okay, next thing says be careful and show your work. Okay, this is huge. And I know that every teacher's like, show your work. Blah, blah, blah. This, you need to show your work for your benefit. Okay, meaning that these are things that you can't really do in your head. Okay, I can't do in my head very well, and I've been doing this for a while. It is helpful for you to write down, use paper. Okay. And then the last thing says we solve equations using inverse operations. Logs and exponentials are inverse. This is what I talked about up here. Okay, just know that we're going to change back and forth. Okay, and that is the main idea of today. Okay, so here we go. First example. This is in log form, meaning I am going to try and change it to this form. So I need to figure out what is what. So 4 is my base, this is my A, and this is my E. So I'm going to change forms, and I go 4 to the negative 1 equals x minus 5. Well, 4 to the negative 1 is 1 over 4. And I'm going to solve for x. I'm going to add 5, and I get x equals 5 and 1/4. Or you can write it as 5.25. I don't care if you use a calculator. And then I'm going to check to make sure that it fits in my domain. And the way I do that is I say log base 4 of 5.25 minus 5. I need to make sure that this part is not negative. And it's not, so we're good. So this is my answer. Okay. Next one. Oh, let's do orange. Okay. Whoa. How do we solve this when there's 2 logs? Well, a couple of things. We're not going to have to change forms because if you notice, this says log base e of x minus 3 equals, if we know our exponent rules, remember this comes up, and we get log base 3 of 2, oh, not 3, sorry guys, log base e, because it's the ln, of 2 to the third. Which, what is 2 to the third? Well, that's 8. So I really have log base e of x minus 3 equals log base e of 8. Well, if these are the same, then this has to be the same. So really, I just need to go x minus 3 equals 8. And solve from there. I add 3 to both sides, and I get x equals 11. That's my answer, but I got to check and make sure. And I go the ln of 11 minus 3. That stays positive, so we're good. That's an answer. Okay. Now this one. This one doesn't look anything like the other two, but do you notice how there's not a log? Okay, there's no log in there. So that means that I'm going to try to get it. So we have log base b of a equals e. So I got to get rid of some stuff. There's some extra stuff. This 50 is extra, so I'm going to take both sides and divide by 50. That cancels there. And then so I get e to the 0.035 equals 44. Not 4. Not 40. 4. Okay. So then I have this. I have a base, I have an exponent, and I have an answer. So I can change form. So it says log base e of 4 equals 0.035. Okay, so that's really the ln of 4 equals 0.035. I think there's supposed to be an x on here. We're going to do that. We're going to put an x there. And then the way I solve that is I would go 0.035, 0.035. So x equals ln of 4 over 0.035. And I'm fine if you leave your answer like that. Totally okay. Okay. On this one, we do not have to check for domain restrictions because it's not a log. It doesn't start as a log. Okay, we only have to check for things that start as a log. Okay, but here's example 4. I think this is our last example. We're cruising. Okay, on this, you might originally think, okay, can I make the bases the same? Because the problems we've done previously were like, can I make them the same so the exponents are the same? But you look and you've got 25, which is like 5 times 5, and 144, which is 12 times 12, and that's not going to work. So we're going to change forms. We have base, exponent, answer. So I need it to go log base b of a equals e. So I get log base 25 of 144 equals 2x plus 1. Okay, this, if you remember from our last one, we're going to have to use the change of base formula. So we're going to use a calculator. We get log of 144 over log of 25 equals 2x plus 1. I get a calculator out. I figure out what that is. Log of 144. Make sure I close my parenthesis. Log of 144 divided by log of 25. And that's like 1.544 equals 2x plus 1. I'm going to minus the 1. So now I have 0.544 equals 2x. And I'm going to divide by 2. And I get x equals 0.272. Okay? Pretty simple. You're going to kind of combine all the tools that we've had in previous lessons to solve. Remember when we solve, that means that we're going to get x equals. That's how we know that we are done.